So good morning, everyone. First of all, I would like to wish you a great new month of July with amazing summer holidays coming. Welcome to our webinar speaking about the digital treatment planning workflow with Nemocast software. I'm very happy to share this webinar under the hospitality of Smart Aligner Services company. And of course, I would like to say a big thank you to all of you who are attending this webinar and spend some time with us, your morning time, to share our knowledge. I would like to make a small introduction of myself. Dimitris Fragkos. From those who do not know me, I'm from Greece, and I live in Athens, the capital of Greece. I don't know how many of you have visited our beautiful country. I would highly recommend that you visit us, especially the summer holidays. I'm Dimitris Fragkos. I'm the CEO and founder of Plano. I would like to make to tell some words. I would be more than pleased to meet each one of you in person, get to know each other and exchange ideas and knowledge. You know, technology is here today to connect us for this webinar, but the human factor is the one, in my opinion, that will always be the most important part of our job. Of course, we have artificial intelligence nowadays, and especially in digital dentistry, but we must always remember that human intelligence will always be present and crucial for our jobs. I'm the CEO and founder, as mentioned, of Plano, digital treatment planning company. This is the first ever digital treatment planning company in Greece. You can all visit our brand new website, review our services, and of course, use our new application, Plano Connect, where you register and communicate all your cases, review them, and modify them and approve them for aligner production. I have a solid background in digital dental technology since 2007, and I'm specialized in orthodontics. My digital journey started around 2015 and continues until today. I'm also the chief technician of Secret Aligner System from Austria, Vienna. I must also mention that I'm an expert user of two cutting-edge softwares, Nemocast, of course, and 3Shape software. And I'm also an active member of European, German, and Austrian aligner societies. I would like to start by giving you some information about Nemotech company and Nemocast software, of course. Nemotech is established in more than 73 countries around the world and has 30 years of experience regarding the digital dentistry. Nemotech is in the group of Biotech Dental, which is a big company with multiple options and services and great support. Regarding Nemocast, it's a software since 2004, and since now it has developed a lot following the state-of-the-art technology of the dental dentistry. It has also the Nemo Studio Cloud, which is a very productive and collaborative platform. You can save all your cases in your cloud account, share them, and communicate all your cases fast and efficiently with patients, doctors, labs, and of course, work with complete safety. And last but not least, Nemotech has its own educative platform, Nemo University, where there is a monthly calendar for multiple webinars, courses, mentorships, either live sessions or recorded video tutorials. This is something very important, in my opinion, for every user to learn, to educate, and increase his learning curve. Our main focus in this webinar will be divided in 4 parts. The preparation part, the digital setup part, the exporting part, and of course, at the end, I will have the questions and answers, where I will try to answer all of your questions. Just for your interest, I would like to mention that the flow of the presentation will be like this. Each part will have a slide with some main bullet points, and then we will continue with a small video animation in higher speed, where we will try to explain each part inside the software. All your questions will be answered as mentioned at the end of the presentation, and I hope I'll be able to answer them, all of them. And for any questions you may have after the end of the webinar, please do not hesitate to contact me via LinkedIn or Instagram, where we can have some further discussions about the software and generally for digital treatment planning. Starting with the preparation part, as soon as we collect all the data needed, such as STL files, such as photos and X-rays, and of course the DICOM, if it is available from the clinician, then we start creating the digital basis from the STL files. We superimpose the photos and DICOM with the models, and then we start segmenting teeth, placing some teeth landmarks, and segmenting the roots. Otherwise, if we don't have the DICOM, we follow the same procedure without it, and without the last part of the segmentation of the roots, obviously. Starting with the preparation, before beginning our main presentation, I would like to mention something very important about the workflow of the Nemocast software, and have it as a general rule. We start with the upper toolbar, like you see here, from the left to the right. And as soon as we press a button from the upper toolbar, let's start, let's say, from the orientation button, then we follow the left vertical toolbar from the top to the bottom. And it goes like this. We press then the digital basis button, and then we continue to the left toolbar from the top to the bottom. And then we end up to the segmentation button. We click it, and we continue to the left toolbar from the top to the bottom. This is a general rule that we always follow as a guideline for the Nemocast software. And at this point, something else very, very important. You must always remember to save your progress after each step. We don't have the autosave function in Nemocast because it's a cloud-based software. So you must always have in your mind saving each session. In order not to lose any of your cases, because if you forget to save your progress, maybe you have ended your digital setup, and something happens, the software crashes, or you have no battery or anything, and you may lose everything. As mentioned, if the DICOM is available, we must import it at the beginning before all the data we have. and then we import the photos and the STL files to start preparing the case. Let's start from a small video where we show the beginning with the DICOM. We start superimposing the DICOM with the models to find the correct orientation of the models based on the DICOM we have. And as soon as we have finished both upper and lower jaw, we continue with the digital basis part and with the segmentation of the teeth and placing the landmarks, and we start segmenting the roots. The first thing we must do is tracing the apex of each tooth. This is done by monitoring each view from each window we have here. As you can see, we have the axial view, the sagittal view, and the coronal view. And as soon as we find the correct apex, we apply it, and then we start the automatic building of the contours. And if needed, we can draw some contours manually. We then build the selection where we have the root and the crown built together. And we finally deform the gingiva in order to adjust the gingiva with the new contour of the root, because before we had only the roots, the crown, sorry. And of course, as soon as we finish this procedure, inside the digital setup, we can have a total overview and a complete overview of the roots while moving the teeth, and how the root is moving inside the cortical bone. We always prefer the 8-photo pattern with 3 extraoral photos, as you can see here, and the 5 intraoral photos with the lateral and the panoramic X-ray. We import all the data by the simple function of drag and drop. And then, after importing the photos and the X-rays, we import the STL files here. We import the upper model, the lower model, and we finished this procedure. Then we proceed to the 3-plane orientation. We load the frontal photo with a smile. And with some tools, we have the ability, like the drawing the inner lip line of the patient, in order to visualize the final setup based on the photo of the patient. We align the models with the purple crosses you see by using these arrows on the left panel, clicking these arrows according to the view we have and the orientation according to the axis we want to. Let's see it in our video, also this procedure. We load the icon of the 3D models, and we start the orientation of the 3 planes with the guidance of the purple crosses in each of the 4 windows. We adjust everything with small arrows, and then, of course, as soon as we finish this procedure, we click on this icon. We load the frontal photo with a smile from our library, and we start placing as much mark points as we can, one to the model and one to the photo. We must always remember that the photo is a 2D file, not a 3D file. So the more mark points, the better the quality of the superimposition. Imagine that here in this case we have placed over 10 mark points in order to have better quality of superimposition. And after placing these mark points, we start drawing the inner lip line, where we have the ability to visualize the final result inside the patient's mouth. You see, we start drawing the splines as soon as we close the line, and then we click on the new button, we click on the mapping, and we have this result. After finishing the superimposition, we start creating the digital basis by checking the mesh, drawing the contour around the model. Always remember drawing the contour counterclockwise. We'll see it in our next video. And then trim the mesh and extrude the height of the base. We click on the digital basis, we check the mesh for possible defects the mesh has, and repair them if needed. Then we start drawing the line, the contour, always counterclockwise until closing the line by clicking at the end, the right click and click end. Then we adjust a little bit our splines in order to have the correct shape. We trim the mesh and we extrude as much as we want to. I always select around 3.5 millimeters. The teeth segmentation starts right after the digital basis. We check again the mesh. We select the teeth for the segmentation we want, and then place all the points on the teeth. I would like to mention an example, like we want to have a setup of social 6, so there is no need to segment all the teeth, but only from the first premolar to the first premolar, in order to have the final contacts distally of the canines. So you gain time with your workflow. As soon as we select the segmentation button, we check again the mesh and repair it if needed. Then select the teeth from the table with blue marks. Here we select from 7 to 7. And then we trace its tooth by left pressing our mouse from the center of its tooth and drag it either to the mesial side or to the distal side, according to the quadrant we are. As you can see here, we have a totally guided procedure from Nemocast. It has the identity ID mesial 13, which means that we have to drag from the center to the mesial side of 13. Here we have ID M12, from the center to the mesial side of 12. ID 11, and so on. As soon as we finish the first quadrant, we go to the second quadrant. We have ID distal 21. So from the center to the distal of tooth 21, ID distal 22, and so on. The second part of segmentation is to convert all the points we placed before to contours for each tooth. So we have to segment, obviously, the teeth from the gum. We must select the type of the impression here. Either it's a lab scanner or intraoral scanner. From my experience, even if it's a lab scanner, by clicking the intraoral scanner, we have a better impression of the contours. We start adjusting all the gingival margins, as you see, by clicking the splines and adjust them. We can edit the contours here by clicking the button and having the pencil tool, which is quicker than clicking each spline individually. We always pay attention for any overlappings between teeth, because otherwise the software will not allow us to proceed and it will appear an error. And as soon as we finish, we update the papilla points and we finish with the segmentation part. At this point, I would like to mention that the segmentation part is a very crucial part for the predictability of the treatment planning and the accuracy of the teeth dimensions, along with the future interproximal contacts and collisions. I know that it may seem to everyone a very boring part, but we must always remember that the beginning is the half of everything. Regarding the teeth landmark session, it is calculated for each jaw separately, and it helps the software to identify the interproximal and occlusal contacts and activate some AI functions like auto-alignment. The calculation of the teeth landmarks is made automatically by the software. Sometimes we need to adjust a little bit some landmarks or apply them manually under the guidance of the software. You see distolingual cast tip. Every teeth landmark has a label where we understand which teeth landmark is, and we can adjust it a little bit in order to have better quality of some functions inside the digital setup. Ending this part, I would like to mention and welcome a great function that will be launched very soon from Nemotech, and it is called auto-segmentation. With this function, we import all the data mentioned before, including DICOM, if it is available, and along with the STL files, the software will automatically segment everything, crowns, roots, nerves, within some minutes. And imagine that only for the root segmentation, it is a very time-consuming procedure. So as soon as it is launched, it will be a great feature for our workflow and our fast workflow. The second main part is, in my opinion, the most beautiful and interesting part of the digital treatment planning. It is the digital setup, beginning from the necessary measurements we can have, such as bolt-on analysis and teeth dimensions. We then create the arch templates used as guides, and then we start moving the teeth with different type of tools. And after we finish with the initial setup, we then start making some adjustments with the assist of the articulator and the spacing labels function. And as soon as we finish with our setup, we begin the staging part. The staging part, I would say that it's the most crucial part and the most crucial function for the best possible predictability of the digital treatment planning. And based on the sequence of movements from the staging we have scheduled, we can also schedule and adjust the sequence of the IPR needed per stage. And at the end, of course, we place the different type of attachments according to the type and the difficulty of each movement. Starting from the teeth measurements, we can have data for the distal mesial dimensions of each tooth, along with the bolt-on analysis. This will give us some data for how much expansion we may need and the amount of IPR needed. Here are the distal mesial dimensions from where we can have a first rough estimation, which teeth must have the biggest interproximal reduction in order to maintain the best possible symmetries. And of course, regarding the Bolton analysis, which will give us some data for the teeth discrepancies between the upper and the lower teeth, and of course have an overview for how much expansion we may need, the amount of IPR possibly needed, of course, or in some cases possible extraction. Following the ARTS templates, we can select either a single jaw or a both jaw template. We can adjust the templates accordingly with the various tools and settings like symmetries, with the curve of P. We will see everything in the next slides. Here you can see the overview by right-clicking the ARTS guide. All the options can be deactivated, for example, the symmetry and the speaker flat, and can be customized based on the needs of each patient. Here you can see we have multiple options from different type of ARTS templates according to the ARTS form we have for each case. After selecting the one we want, we try to adjust the template by using the symmetries and the curve of P option, of course. We can move the ARTS guide as a whole in order to place it to the correct plane, like here to the occlusal plane. We then right-click the speaker flat in order to adjust the curve of P. And after finishing the upper template, we can have two options. Clicking the lower template, and we can position the lower template. Here you can see that we can import the patient's photo in order to adjust better the upper template. And as I was telling you, we can click then the lower template, and we can position it based on the upper template with the according overjet and overbite. Otherwise, it is not mandatory. We can customize the lower jaw individually from the upper. The part of moving the teeth has many tools to happen. We have three ways. We have the 3D manual tool, the arrows by tooth axis on the left side of our panel, and the 2D manual tool. This is the 3D manual tool, where we have this icon on the left. We have these arrows on the left panel, where we can change the velocity per click on these arrows, and by moving in its axis of its tooth. And at the end, we have a very interesting tool, the 2D manual tool, which is very useful for some kind of movements we will see in our next slide. Excuse me, something happened. I don't know. Very sorry, the PowerPoint has crashed. Let's see it again. We were here, okay. Go. Okay.
Everything okay?
Yes, yes.
Yes, perfect.
So the 3D manual tool has all the arrows needed to move the tooth to all different axes.
Excuse me, Dimitris. Now you are sharing two screens at the same time. Two slides. Is that correct?
Excuse me. Excuse me for this.
Don't worry.
Now we are okay, I think.
Yes.
Let me hide this floating stuff. Okay.
Oh, perfect.
So let's proceed.
Yes.
So the 3D manual tool has all the arrows needed to move the tooth to all different axes according to the view we look at the models. You see here we have the occlusal view. Here we have the frontal view, so we make a movement of tipping or the extrusion, intrusion, and all these kind of movements we can. We can change to the left panel with the arrows buttons. We can change the velocity per click. You see here we have the buttons, the arrows for the tipping, for the talking, and one last tool, as mentioned before, it's the 2D manual tool, where we can change the rotation center, and let's say we can make a hinge rotation, hold the mesial side stable, and move the distal one backally. So this is a tool and some tips for better simulation of the movement and faster workflow. We proceed to the contacts by activating the spacing labels button. We must remember that when we have a positive value with orange coloring like this, then we have the collision, which needs an IPR. A negative blue value means we have a spacing. And finally, the blue value without any positive or negative symbols means perfect contact. Here's the video where you see that while we are moving the teeth, the spacing labels change in real time to keep monitoring the spaces and the collisions, of course, in order to have the best possible setup with the less possible collisions, of course. Another tool that is very important to use and is mandatory, in my opinion, for the predictability and the functionality of the final result is the articulation. We have many options here. As you can see, we have an extra tool of the articulation It's called the option of the articulation inside the final treatment planning. There we can apply a new occlusion, save it, and use it as a new relation to our final setup. As soon as we save the relation, we can jump to the timeline, right-click to the final stage of our setup and select Add Relation. Then a new window opens where we can select from the list we have the occlusion we want. In this case, we have named the new occlusion new. We apply it, and immediately a new box, as you can see, is created with the label of the name we have created before. This box can be adjusted as we want to, either leave it as it is, like you see in your screen, which it will be animated as a byte jump, or integrated all along during the whole setup, as you see here in our slide. Let's see a small video with the simplest function of the articulation. We click on the distances button. We adjust the box distances and apply 0.1, which is the minimum collision. And we start moving the teeth. You can see that while moving the teeth, the contacts change in real time. They change colors according to the values we have applied before. Here we can also use the left panel, the left control panel, by moving the teeth. And of course, we have a great option, a great functionality where the lower gum is has its opacity, which helps us a lot to visualize the occlusal contacts. And one last useful tool is the slice view. As you can see, according to the view we have, we right-click, click slice view, and then the software slices the models to check the intercuspidation. We move the teeth we want to have the best possible occlusion. Regarding the staging part, we have many options, like setting the velocity protocol. We will follow per aligner, combine or separate some movements, increase or reduce the velocity, and divide some movements, like stop them and resume them to a next stage. Regarding the velocity protocol, we will follow per aligner. We apply the values we desire, and always we click on the box divide movements in components. In that way, we do not have only the two main categories of the movement, such as translation and rotation, but these two main categories are divided into different components. These components are the following for each category. For translational are the lingualization and protrusion, mesialization and distalization, and of course, extrusion and intrusion. And for the rotational are the torque, the tip, and the rotation, which are measured in angles. By entering the timeline menu, we enter to the world of staging. As mentioned, we set our protocol. Here we click to the settings icon. We set our protocol, let's say 0.2 and 2 degrees per aligner, and we divide, we click on the box, divide the movements in components, and we start making the staging, adjusting the sequence of movements by dragging the whole bars. You see we can stretch the bar by changing the velocity. here the software notifies us. It turns the whole bar in red, which tell us that you are over the protocol you have applied before, but you are free to do it. The software allows us, but it notifies us. We can also divide some movements. You see the lingualization movement is being divided in 2 parts. So it stops in the number 1 and it continues to from the 3rd one and 4th. And then we can have a step-by-step animation with moving our cursor to animate our sequence of movements inside the timeline. In the following video, we will give you a small animation example from a crowding case. It's an easy case, okay? Just to see how the bars are working and see the sequence of movements we have followed by adjusting the bars for each type of movement. As you can see, we have created first a small spacing for the tooth 31, which is crowded, by proclining the teeth 32, 41, and 42. And after starting moving the tooth 31 for better predictability and control of the sequence of the collisions and the need of IPR. And of course, in this video, I would like to show you how we do the sequence of the IPR per contact. We check the orange values at the final stage, and we right click, and the purple box appears according to the purple value we have. We set all our IPR values. Let's say in between 33 and 34, we have a 0.3 millimeters. And as soon as we finish oral values, we start clicking step by step on our timeline. And as soon as we see the first orange value, we drag the purple box of the IPR to the specific stage we have the first orange value. To this point, I will also like to mention that you can consider adjusting some IPR points by changing the sequence of movements a little bit more in order to have the best possible IPR appointments with the more grouped IPRs at the same step, because we all know that an aligner therapy is a kind of treatment that the patient doesn't want to have many appointments. So I suppose you, the clinicians, want the same thing. So we must have all these things in our mind as technicians in order to make your life easier, and not your life also only, but the patient's. We are finishing the digital setup part with the placement of the attachments. We can easily move them, scale dimensions, copy and paste them, and save them as new attachments. We can select from our library the appropriate attachment for the specific movement we want to have. We can move it with the 3D control tool. We can scale the dimensions, of course, to the desired ones. You can see that while scaling the dimensions, we have a real-time dimensions of the attachment. We can scale it to all the dimensions to any axis. We can copy this attachment and paste it, let's say, to the tooth we are, and have a couple of forces like a yin-yang attachment, or copy and paste it to a different tooth. And as soon as we are happy with our dimensions, we can save it as a brand new attachment, and we can use it. We can have it to our library and use it to our future cases, which is a very nice tool and very fast tool. In this part, we will see another option regarding the attachments. It is the possibility of applying an attachment from the beginning, and we have the possibility to remove it at the end of the aligner number 6, for example, here. We just right-click on the specific number of aligner, and a new icon is appeared. You see the green icon, remove attachment 1. We can also have another option. It's a reverse option, beginning with no attachments and apply one at the beginning of aligner number 7. We just drag the attachment icon inside our timeline at the beginning of the aligner number 7. It is an easy procedure by dragging the icons of its attachments on the specific tooth. One final amazing option we have in Nemocast is a virtual tooth. In this case, we have an extraction and a big space at the beginning where we apply the virtual tooth, which is adjustable during the stages, and it is removed by us here until the space is smaller than 2 millimeters. And we are sure that we won't have issues for the aligner to stretch during the vacuum forming procedure. We can also have, here in the virtual tooth tool, the reverse option, like creating a space. We want to create a space for a future implant where we adjust the virtual tooth and it gets bigger during the stages. And this is the time we must export the PDF report with all the data and for the IPR and attachments applied. We click on the icon, the printer icon, and then we click on the summary setup print. And a new window opens where we must click the PDF button, apply the doctor and the clinic names, and then the PDF file appears with the data in one page. This is the format you get from this PDF file. And let's go and see in details what is the meaning for each information. Here we have the total number of aligners. Here it's an example only. We have 0 aligners for the upper one and 14 for the lower one. Continuing below, there are some icons which explain what we see below on the teeth chart, like the red indication of the IPR, or if we have applied any elastic hook or a button cut. And so it is on the right side to the next slide. Here we see what type of attachments we have applied and if there are some missing or extracted teeth. Going below, we have a clear view in which contact we have an IPR, how much amount and before which aligner we must apply it. The sharp symbol you see before the value of the IPR means the number of the aligner. So let's see an example between 43 and 42 teeth. We must apply 0.3 millimeters before proceeding to the aligner number 5. And at last, we have the complete overview of all the movements per tooth and per axis. We finished with the second main part, and we have the last main part, the third part of our workflow, which is the exporting of the files for printing. We start cutting the bases, applying some flat ends for vertical printing. And of course, we can hollow our models The next function is the labeling part and the numbering part. Then we can have also the trimming line, which either can be made as a Markov models or the trimming line for automatic aligner cutting machines. And we finish with the direct printed aligners. Of course, with Nemocast, we couldn't miss the functionality for direct printed aligners. And we finish with the exporting of the models. Let's present some more details. We can select the complete setup to export or specific stages, let's say from 0 to 5. We can have two different options of hollowing, hollow out and hollow down. We can adjust the plane cut to cut off the base as we want to with the different angle, and we lock the biomodels to proceed. Here, let's overview the whole toolbar regarding the biomodel setup. With these options, we can select, as mentioned, the complete setup to export or specific stages. Let's say we want from 0 to 10. We apply to the initial box 0 and to the final box the number 10. We proceed below to the options. We have two options for hollowing the models, either hollow out or hollow down. Let's see the differences. The hollow out option is that the model is hollowed inside but closed at the base, at the top of the base. And the hollow down is a complete hollowed model with a specific thickness around the wall of the model. And then we proceed to define the cutting planes. Here we can decide and adjust how much height we want to have for our models in order to save some resin material to our printing procedure, change the angle of the cutting plane, and maybe adding some flat ends used for vertical printing. We lock our biomodels and proceed to our next stage. Here we have a small video. We adjust the planes. We first select whether we want hollow out or hollow down, and then we select our planes, how much we want to cut our bases. Here we can adjust the angles because sometimes the insertion direction of the anterior teeth is difficult, so we have to change the angle of our model in order to be vertical, the anterior teeth vertical to the aligner, which will be vacuum formed. The labeling part consists of the naming on the models and the numbering on the tooth. We can name the labeling as we want to, with the patient's name or whatever we want to, and place it either at the side of the model, like here, or at the base of the model. And then we apply the numbering on the tooth surface we want to, which will be a mark on the 3D model. And after, it will be impressed on the aligner with the vacuum forming procedure. The aligner's bottom menu has the trimming line tool and the direct printed aligner part. Here we will see in details all the buttons used for the cutting line part. First is the cutting line. We have to activate it in the box, and we select the Markov model, as mentioned, which will be printed on the 3D model, and it's a great tool which will be our guide for the manual trimming procedure by the person who does it. Imagine that we have a new employee, so we want to be familiarized with the cutting procedure, or in general, for our production line, we want the production line to be specific from any person it is done. So in that way, with the Markov model, we have a specific continuous result. And of course, if we don't want to mark it on model, of course, we can have the trimming line for the automatic aligner cutting machines. We will see the whole procedure to an upcoming video. Here we have the aligner tab. We click on it, and the direct printed aligner session starts. Here we will see all the procedure. As soon as we activate the trimming line function, we can mark on model, or we can select the cutting line for the automatic aligner cutting machines. This line can be adjusted from totally straight or scalloped, or we have the ability to draw it manually and draw some precision cuts or some button cuts like here on the molar. We can edit it manually as much as we want to. And finishing with the direct printed aligners, where we adjust the thickness and the offset according to our needs. Here we apply all the parameters to all the stages, and here we have the direct printed aligner function, where we select the thickness, the offset, and we are ready for the export. Finishing with the exporting function, we can either select one jaw or both jaws according to the setup we have made, and select the exporting path we want to our local disk. The procedure is very fast and very productive, I would say, because I have experience from other softwares also. It takes around 30 seconds for 10 models, which is very, very fast. And after finishing the exporting procedure, all we want is the production line with some 3D printers, either for having the models for vacuum form, the aligners, or have the direct printed aligners. So, I would like to say a big thank you to our sponsors who support us a lot. First of all, the Smart Aligner Services Company for their hospitality and their professionalism. Thank you very much again for this opportunity. Of course, Nemotech company with their amazing Nemocast software and their support. Our company Plano, digital treatment planning company. Then Al-Secret Aligner company, which is an Austrian aligner company in which all aligner cases are planned by experienced orthodontists and dental technicians. I'm using a special version developed for the aligner company Al-Secret, where we have special functions like additional attachments and online editing tool. And of course, TPAO Congress, and personally Matthias Pepper. Speaking about TPAO Congress, We are very excited to have the biggest congress in digital treatment planning with amazing speakers, both clinicians and technicians. And I would like to say that this is the way our knowledge sharing and our collaboration between clinicians and technicians will be fundamental to take the digital treatment planning to the next level. So we are waiting you all on November 24 and 25 in Hamburg. And speaking about congresses, another interesting congress will be held in Austria, Vienna on October the 6th. It will be the first congress of the Austrian Aligner Society with great speakers and sponsors. So do not lose the opportunity to take part. So this was my presentation. I would be more than happy to answer your questions and help you with my answers. Thank you very much. Enjoy your summer holidays. I hope you didn't get tired, because watching a software presentation without being able to follow like a hands-on is a little bit weird. So the practice, I would say, is the most important tool we may have to increase our learning curve, and it applies, at least for me, to every part of my life and my job. Thank you very much again. Luis, you have.
Dimitris, I have a question.
Yes, please, Thomas.
You've mentioned the automatic segmentation in the near future. Is there a possibility to override it?
What do you mean override it?
I mean,
to skip it.
Yeah, I mean that it will be automatically made, but you do have the possibility to correct if in your opinion it's not quite correct.
Yes, you have the option to start a manual procedure like we presented, or the automatic one, and you can adjust a little bit these results you have. But I'm informed that this procedure is very precise, and we have a very good quality of the auto segmentation. It is not launched, still not launched. I think until August, they will have it.
Okay, thank you. And the second question, in your experience, if you are more or less skilled with the Nemotech, how much does it cost in time to have a setup from the beginning till the end by a not so complicated crowding case?
I would say, Thomas, that from the beginning of the whole procedure, from the preparation part to the exporting part, I would say an average time of 75 minutes is a good time to have an average case. Of course, for an average user, not a beginner, not an expert user.
Okay, thank you.
You are very welcome. We have any other questions? I would be more than happy to answer you, or of course, if you have a question and have it after the end of our presentation, do not hesitate to send me or send to Smart Aligner Services, and they will contact me and give you the answer. I see some friends also. Hello, Irene. Anyone? Please feel free to ask whatever you want to, whatever, even if it seems simple.
Thank you, Dimitris. It was a very informative, a very good webinar.
Thank you very much, Thomas, and thank you for attending the webinar. Thank you very much. So everyone else, Luis. Thank you, Elena. Thank you very much. Thank you, Hakan, for attending. Okay, Luis, I think maybe we do not have any questions. Should we wait a little bit more? Are you using graph erasing from Eileen? No, I haven't experienced yet the graph erasing. I think it's the future, but of course it's under development and under testing procedure. Of course, we can have some sample cases. Everyone can make sample cases in order to see how it works. But I haven't experienced the graph erasing for direct pedit aligners. Usman asks about eruption bubble. Can you specify your question? Yes, if I understand your question, we have some sculpt tools where we can sculpt some bubbles or fill some holes. Or any baby tooth is ready to erupt. Yes, probably in this case, we can have a virtual tooth to this area in order for the aligner not to cover the part of the gum where the baby tooth will erupt. So this is a solution, I would say, in my opinion. I'm seeing the chat. What kind of precision cuts can I make? From Thomas. From the tool we mentioned in the trimming line, you can draw whatever you want to, really whatever you want to. In any area, in any tooth you want, you can design anything. And I mean for the automatic aligner machines, where you have the trimming line drawn, and then the machine cuts and applies the precision cut according to the trimming line you have applied. Yes, it's the same for the button cuts, exactly. If we are speaking for the automatic procedure. Yes, of course. Thank you very much, Irene. Thank you for attending, my friend. Usman has a question. Trimming line nowadays are being used straight. Which is better? From my experience, from the scalloped one, we lose some anchorage and some retention. So with the straight one, we have better retention. And of course, in the aligner cases where we don't have many attachments, we must always select for a straight cut line for a straight trimming line. But it's up to the clinician, I would say. Many clinicians prefer only scalloped, and they are very strict with this. I would say a good compromise is having a scalloped design to the buccal surface, and palatally or lingually, we have a straight line, because it's very often that the scallop design lingually annoys a lot. It's very annoying for the tongue and for the patient. And maybe we don't want for the patient to feel uncomfortable, especially with aligner therapy. Bite adjustments is possible, of course. Of course. We apply, you mean bite adjustment, you mean bite jump or bite ramps? Usman, please specify. Thomas, I'm in your mind, Thomas. Bite ramps. Yes, they move automatically. They can be applied like attachments, palatally to the upper incisors, and they are applied from the step we want to, let's say from the beginning, and they adjust as we want to during the treatment. And the bite jump, Usman, I mentioned that we can create a new relation, a new occlusion. Yes, we add the new relation to the timeline, and we can have the animation of the bite jump at the end of our treatment. And Thomas, can I specify the jumps? Yes, you can specify it. You have all the tools and the settings. Yes, of course. We have everything. We have all the settings, and we can adjust all the settings manually in order to have the visualization of the jump we want to. So it's all customizable. Another question. Thank you, Thomas. Thank you for your presence and your attendance. I really appreciate it. Thank you. Thank you, Usman. Thank you. Have a great rest of the day. And I wish you great summer holidays. Any other question? Either in the meeting chat, or you can take the word and exchange ideas and make your question. So, Luis, are you with us?